So 114 is called function model construction and application. First of all, the word model becomes important because it will start to ask you to define a model to represent data. And what that means is come up with an equation to represent the data if it was charted on a graph. So what our calculators do is we're going to learn how to insert the data, and then your calculator, when given direction by you, will learn how to actually create an equation for you given the data.
This is the last lesson
Before the quiz, yeah, and it's only part of this section. Like I'll tell you exactly what it's going to be. Yeah,
It's not entire.
it's not the whole section. Yeah. All right, so first of all, these are the basic forms of regression. We are going to build on this as the year goes out. We will add exponential and we will add log and sine. Okay, but for now we're talking about linear and quadratic. So these little dots represent data or stats. So you're going to get a chart. It's going to give you that data, and then I will teach you how to plug that into your calculator and see it, but you can also hand draw these. So something that is linear does not have to be perfect in a line. This is a model that is an approximation of the data. And so something that is linear would look linear overall in shape. If I could draw, this is called your line of regression. If I could draw that, it has a linear shape, but it is not perfectly linear. We're going to learn that each of those dots, if they go above and below the graph, we're going to learn how to, not today, but we're going to eventually learn how to find what's called the regression or the residual, which is the difference between the actual and the line itself, okay? And then we're going to talk about how that affects your data. But for now, you're looking at an overall shape. So that's linear. Oh, hang on. Okay. Then quadratic, it takes this overall shape here, like a parabola. And then cubic, it usually starts down, comes up, and then goes back up again. So that's your overall shape. Again, it's not always going to be perfect. A perfect model would be amazing, but it's not usually perfect. The models that we come up with are an approximation of the shape that would result in that data. So what are these used for? A model could help you predict what could happen in the future. A model could help you compare what did actually happen. So you could get something like, over the course of this amount of time, either temperature is measured or population is measured or something like that, and there is a model created. And so with that model, what does that tell you might happen in the future, okay? Or what happened, that actual data, was it as it should have been predicted, or was it an over approximation or under approximation, okay? Or overestimate and underestimate. So these are where we're going to start with a linear, quadratic, or cubic. So on this example, it says plot the data on a coordinate plane, determine the best model for data, and then we're going to get into the graphing utility. So in this case, it says, here's my chart, year 1994, 98, 2000, all the way down, and then the net worth in billions. This will make you very upset that somebody can make this much money. That's what this data does to me. It's ridiculous, okay? But if you look on the bottom, so first of all, left-hand side says net worth in billions. That's what this is, okay? Billions with a B. And then on the x-axis, it says year since 1994. So we are not just simply going 0, 12, 10 like that. We are going years since, 94, 98, whatever. We're going years since 94. So how many years would it have been since 94 if it is 94? This would be 0, okay? How many years would it be in 98? 4. And then 2002, so you can either subtract 94 from this or just keep up. From 98 to 2002, it's 4 more years, right? So this is 8. From 2002 to 2008, it's 6 more years. So this is 14. From 2008 to 2015, it's 7 more years. So this is 21. From 15 to 18, it's 3 more years. So this is 24. And from 18 to 20, it's 2 more years. So this is 26. So the first thing you have to do is figure out how many years it is since 1994. So again, I could have individually subtract 1994 from each of these, or you can go up in the pattern that we just did. Now we're going to plot this data. So he was sad and lonely and probably homeless in 1994 because he had $0 billion. Shh, we're going to say he's homeless and sad. Okay, then 4 years later, miraculously, he goes to $12 billion. Could just throw one of them our way. We'd be good. And then in 2002, which is 8 years, he's at $10 billion. So he dropped. So sad. Poor, pathetic guy dropped to $10 billion. 2008 was a rough year. He only had $2 billion. 2018, he had a great year. 24 years in, he's all the way up at 100. And in 2020, $136 billion. So 26 years in, 136. All right, so step one, obviously plot it. Now think about the overall trend here. Does this look linear? No. Does it look quadratic? No. It's going up, coming down, and coming back up again, which typically is cubic. Did I plot something wrong? 2015, 2150. I sure did. This one here. Thank you. Okay. So I think this is cubic. Okay, that would be my guess if I had to do it off of a hand-drawn model. Now we're going to enter it in our graphing utility, and we haven't done this before, so please do it alongside with me, okay? First thing we have to do is turn on two things on our calculator. Okay, so in the settings, so in mode, we're going to go to mode, and in the blue on mine, but kind of close to the bottom on yours, there's a thing that says Stat Diagnostics. You need to turn it on. So yours will probably be off. You need to turn it on. Stat Diagnostics needs to be turned on. Well, I'll explain why later. That's first thing, okay? Second thing, everybody has it turned on? And every time you reset your calculator, it goes back to off. So if we're resetting before a quiz or a test, you have to remember that you turn it back on. Does that make sense? Stat Diagnostics go on. Then I have to turn my stat plot on. So second, y equals, gets me to stat plot. And I make sure plot 1 is on. So stat diagnostics on, stat plot on. If you hit enter, like if you just hit enter on it, it'll bring you to this screen, and then yours is probably off. Go to on. See these guys, that's like those are your other options for graphing, right? So we're not gonna do any of that, but that's like your little blocks and whiskers and that kind of stuff. Okay, so get out of there, go back to your home screen. Both things turned on, yes? Okay, now we're gonna enter data. To enter data, we go to stat, S-T-A-T, stat. And we click on edit, enter. And we get these lists. And you're going to enter the lists that are there. So I'm going to do 0, 4, 8, 14, 21, 24, 26. And then where it's list 2, I'm going to enter my Y's. 0, 12, 10, 2, 50, 100, 136. So all your data goes in list 1, list 2. Huh? This is in billions. Yeah. You don't want to write in 12 billion. Everybody's good so far? Yeah. You go to stat and then click on edit. This is like all of this you're doing on your quiz on Monday. All of this you're doing on your quiz on Monday. On Monday. Uh-huh. Uh-huh. Since last week? But it doesn't matter. It could be since Monday. And you're still getting the quiz. Yeah. Yeah. Yes. Yes. All right. Now I go to graph and look what happens. I see little dots. You see the little dots? The dots is your data. Now think about our window, right? How big did it get? What's the biggest Y? What's the biggest Y in our chart? 136. So if I want to see all the data, I have to adjust my window. And my biggest X is 26. So I would have to adjust it. Or you go to, I think it's window. Nope. You go to zoom. and you go all the way to the bottom. Wait, I think it's zoom fit. I think it's zoom fit. Hang on, let me make sure. And you hit zoom fit. No, dang it. There's one of these. Zoom stat. If you hit zoom stat, it will put all of the things you entered into your window in the window. So it adjusts the window to your stats, okay? So I did zoom and I went to zoom stat, which is 9. And that brings you to that perfect square. Now this should look similar to what we saw, right? Yes. We good so far? Yes. Okay, now we got to figure out how to do the regression, okay? So because we're pretty clear that this is a cubic regression, I'm going to teach you how to go straight to cubic, but then we're going to talk about what would happen if I didn't 100% know if it was cubic, and this 100% will be on your AP exam. It will say what's the best model, and it might give you 3 choices or it might give you an open choice, okay? But the way we do it is we go back to stat, and we arrow over to where it says calc. And then in this list, notice 4 says linear, well, it says linreg. That means linear regression. 5, quadreg, means quadratic regression. 6, cubic reg, means cubic regression. Eventually we'll get to quartic. That's just another form of linear. ln will be your log, and there's exponential. Today we said this is cubic, so we're going to hit enter on cubic, and this little menu pops up. And it's asking you what data do you want me to use to create your model? So if I had L1, L2, L3 filled, and there was more stuff in there, you have to tell it which of those to use. Well, we're only using 1 and 2. So our X is L1, our Y is L2. We leave that alone. And then I'm going to go all the way down. Now this store reg is allowing your calculator to take the model it makes and put it into your Y1 so that you can use it later, which we need to do. So I go into where it says store reg, and I do alpha trace to pull up that little Y1, and I hit enter on the Y1. So I put Y1 where it says store reg. I want it to take the equation it's going to make, and I want to put it in my Y1. And then I go down to calculate, I hit enter, and it calculates the regression for me. And then the A goes where the A is, the B goes where the B is, the C goes where the C is, the D goes where the D is. Now here's something that's super important on this screen. Okay, and that is your R squared. You see the R squared there? Y1. So you see that R2? Yes, or the R squared? The R squared tells you how close to your actual data this model is. The closer that number is to 1, the more accurate it is, the better model it is. So if we didn't know if it was cubic, if we just looked at it and said, oh, this could be quadratic, this could be cubic, then I would run it cubic, and I would write down my R squared. And then I would run it quadratic, and I would write down that R squared. And the R squared that is closer to 1 is the better model. And it literally, I think on this one, it's like 0.9956. And then it could be like that, 0.9957, and the 0.9957 is the better model, okay? So because that's pretty close to 1, I know I've done a really good job. If it was exactly 1, it's a perfect model, which doesn't typically happen. But that is what it would look like. Okay, now if I hit if I hit graph, not only do I see the stat plot that I had before, but I also see the model that it created for me. Now they didn't go perfectly through those dots, which is why it's not a perfect one.
How'd you get the line?
Did you store it in your Y1? So when you go to stat, calc, cubic, you have to put it, store reg, alpha, Y1. Alpha trace, Y1. And then I go to calculate and I hit enter. And then I'm going to screenshot this because we need these. Stop recording. Okay, so now when it says find the regression equation for that should be this should be fit. Best fit curve, not best fur curve, okay? Then this is y equals, or f of x equals, or in this case, like if it gave you variables, you could make it A is 0.028. We're going to keep 3 decimal places. X to the third. Minus 0.6996 means the 6. This bumps that guy, bumps that guy, bumps that guy. So 700x squared. Plus C, 4.7078, so 708x, plus D, 1.0915, which is 1.092. Okay, that is find the best fit. So you're going to have to do this on the quiz. We'll practice it again on Friday, but you're going to have to do this on the quiz, okay? And then underneath this, I covered it up, but it says find the average change, rate of change from, and what did I give you? Let me see if I can. Sorry, say it again. 2015, 2023. Okay. So if I want to do a rate of change from 2015 to 2023, then I have to find F of 2023, which is really, it would be 2023. It'd be 3 years past the 26, so it'd be 29 years since 1994. So I'm going to do F of 29 minus F of 2015 was 21 years since 94 over 29 minus 21. Now I stored it in my y equals, so I don't have to type it back in. It's actually better to not type it in because when it's stored in your y equals, it is not rounded. What we wrote here is rounded. What's stored in our calculator is not. So when I do alpha y equals to do the n over n, so I get my fraction, alpha trace y1, 29 minus alpha trace y1, 21 over 29 minus 21. So I have this, okay? And then I'm going to enter. My average rate of change is 22.322 billions of dollars per year. Other thing I would say is that it could ask you to use this model. Listen, it could ask you to predict. You can use this model to predict what could happen in the future, right? So if it said use the model, and it will say words like use the model found, like so if this is a, which is typically the case, like if it's an FRQ, part A will be identify which is the best model. Is it linear, quadratic, cubic? It will give you choices, and you'll figure out from there. Part B will be create the model, so you'll do what we just did to create the model. Part C will be use the model in some way. So either find a rate of change, which we did, or use the model to predict what could happen in the future, or compare if this model, if you compare what it could have been predicted, so I could say, how accurate was it in the year 2002? And we could run it, and we could put 2002's year, which was 8 years after, right, in, and we could compare it to what the data actually was. So those are the ways you'll use it. So if it had asked you to predict how much he would make in 2025, this would be 31 years after 1994. So I would find Y1 of 31 years. So in the calculator, I would do alpha, trace, Y1, 31, and I get $303.290 billion. So typically if they give you something like that and it says billions of dollars, like you never actually have to convert it into dollars. You'll keep your answer in that form. So it might say something millions, in thousands, or whatever, and it wants you to keep it that way. Questions for me, what we covered today. So the rest of the stuff we'll cover on Friday. This is where your quiz ends anyways. So I was going to end up like doing the Okay, so the next skill, and this is an Algebra 2 skill, so hopefully we remember this. This is inversely and directly proportional. This has actually showed up on the SAT, so fantastic if it showed up on the PSAT tomorrow, okay? But directly proportional or inversely proportional, are the relationships between two variables, right? So if it says y is directly proportional to x, then the equation is y equals k times x, where k is a constant. Sometimes they do y equals m times x. You can put any variable you want in there, okay? Your like the AP Classroom stuff will use k, but it just means a constant of proportionality. So if it's direct, we multiply the second term by that constant, which again, this time is k. If it says it's inversely proportional, then we put it under k. So y would equal k over x. So the first one is directly or indirectly proportional to the second one. The first one goes on the one side of the y equals. The second one either gets multiplied by the k if it's directly, or it goes under the k if it's inversely, okay? And the way you will see these are something like this. It says the force in newtons exerted by a magnet, just in case you missed words, on a metal object is inversely proportional to the square of the distance in centimeters. Inversely obviously determines what kind of equation we set up, right? That will either be directly or inversely. So this means the force, which is this first variable, I don't care what you make it, but usually force is F, is exerted by a magnet on a metal a metal object is inversely proportional to the square of the distance in centimeters. So the distance could be my second variable, that could be d. And it says force is inversely proportional, which means the k goes on top. But it doesn't just say it's inversely proportional to the distance. It says what? The square of the distance. So what are you going to do to d? Square it. So that's our model. We just set up, okay, F equals k over d squared. Then it says if a magnet exerts 60 newtons, this is force. So 60 goes in place of the F. On a metal object that's 2 centimeters away. The k is our unknown. Okay, this goes over the distance, which is what? What's the distance in this scenario? It says 2 centimeters away, right? So 2 is your distance. So I get 60 equals k over 4, and k would equal 240. That's your constant. Then it says, which means my equation is now F equals 240 over d squared. So any relationship between force and distance, I will use that equation to set it up. Bye, Giselle. So then it says, what will the distance be when force is 10 newtons? So now F is 10, 240 was my k, and d squared is my unknown. So you can either multiply, cross multiply, do whatever you want to solve here, but this would be 10 times d squared equals 240. Divide both sides by 10. D squared equals 24. And the distance is the square root of 24. If I don't have my calculator, I'm keeping it exact. This would be 2 root, because this would be 2 and 12 and 2 and 6 and 2 and 3. So that would be 2 root 6. And if I had my calculator, I would do square root of 24. Which is 4.898, so 899. And the unit here is centimeters. Questions on that one? Okay, I lied. We're just going to finish it because it's not that bad. What's next is not that bad. We still have till Friday, but questions on that? Okay, last question in this pulls back in piecewise functions. So it says the following model tracks the amount of accumulated rain water during a storm, where X is the time in hours and F is the accumulation of water in inches. And then it gives you a piecewise function. And A says find F of 4. We know how to use the piecewise function? Yes? So F of 4 means I'm going to figure out which of these 4 falls in. So is 4 between 0 and 2, in between 2 and 4, or 4 to 6? 4 to 6 because it says or equal to here, right? So I know I'm using this model. I'm going to take the 4 and plug it in, and that means 8. What does it mean in this context? What are our units? What was the X? What did X represent? the time in hours. So after 4 hours, my f of x was accumulation of water in, I heard it, inches, right? The accumulation of water, or it has accumulated, anything like that, is 8 inches. Okay, now B says find the average rate of change from 3 to 5. So I'm going to do f of 5 minus f of 3 over 5 minus 3. Remember, rate of change keeps coming. So 5 is in between 4 and 6, which means I use that model. F of 5 would be 5 plus 4, or 9. And 3 is in between 2 and 3, and 2 and 3 is just 6, which means f of 3 is 6. So then I get 9 minus 6 over 5 minus 3, which is 2, and I get 3 over 2, or 1.5. You could keep it as 3 over 2, but 1.5, what's the units? Inches per, good, hour. Questions? Okay, so again,